All right, welcome to your favorite class. This is Calc 2. My name is Ron Patton. I hope you're doing well. And I'll be honest with you, like I love Taylor series, really enjoy Maclaurin series, but it doesn't get any better than today. All right, so today, what are we going to do? We're going to manipulate things. I love to manipulate things. So we're going to manipulate either the Taylor or the Maclaurin series. So anyway, yeah, and that's the goal of today is that you're going to be able to manipulate stuff. So let me talk about the most popular or most powerful for these power series. These four are the most popular out there. So I'll give you a second just to write these down so you can put it on pause. Whenever you're doing these, though, a lot of times it's just easiest to just jump in. All right, so jumping in. So we're going to jump in and just practice one of these. So it says find the first four non-zero terms of f of x. So you could take derivatives. If you're taking derivatives, though, the one thing that we do know is that we know that the Taylor series for e to the x is equal to this 1 plus x squared divided by 2 plus x cubed. That should be a factorial over 3 factorial plus yada. Okay. So what happens if I have e to the 2x? Well, in essence, what you're doing is you're taking this 2x and plugging it wherever you have x. So I have 2x plus 2x squared divided by 2 factorial plus 2x cubed over 3 factorial. And that's it. If you want to simplify, then you have 1 plus 2x plus, just remember that this is 2 squared. So this is going to be a 4x squared over 2 plus, just remember this is 2 to the third power. So this is going to be 8x cubed over 6 plus yada. But in essence, that's all we're doing with this manipulation is that you're just plugging in the series that are most common, and then you're getting your results out of it. All right, so let's do another example. So we wanted the first four non-zero terms. One, two, three, four. Yeah, so that's the first four non-zero terms. All right, so example two. Let's say that you have cosine of x and sine of x. So from up above, we know that the sine of x is equal to x minus x cubed over 3 factorial plus x to the fifth over 5 factorial plus x to the seventh over 7 factorial. And we also know that cosine of x is going to be 1 plus x cubed over 2 plus x to the, wait, oh, said 2 and I wrote down 3. So this is going to be x squared plus x to the fourth over 4 factorial. Wait, and I missed a sign. So it should be minus x squared plus x to the fourth minus x to the 6 over 6 factorial. And it looks like, yes, I have made a mistake over here too. So it should be a minus. So it alternates. So we should have plus minus plus minus plus minus plus minus. Yeah. All right. So now what happens? Well, we know that if I take sine times cosine, then in essence I've got this x times this. So I'm taking this first piece and I'm going to multiply it times my cosine. I could have done it either way, okay, but I'm just taking sine times cosine. So 1 minus x squared divided by 2 plus x to the fourth factorial minus x to the 6 over 6 factorial. So what happens if I do that? Then I'll have x minus x cubed over 2 plus x to the fifth over 4 factorial minus x to the seventh over 700. It's really 6 factorial. So now I've taken my first one So I'm good with that. So now I take my second term. So my second term is going to be negative x cubed. 3 factorial is 6. So, and then I'm going to multiply it again by this same piece. Uh, Over here it's written out 4 factorial minus x to the 6 over 6 factorial. All right, and it looks like I'm going to be combining terms. So let me go back up here, and I'm going to change 4 factorial. So 4 factorial is 4 times 3 times 2, so that's going to be 24. 6 factorial is going to be it's going to be 120. All right. So so if I do this, I've got to the third power. So I'm going to have a negative x to the third over 6. I'm going to have a plus, because negative times negative, x to the fifth over 12. And then I've got, so this is going to be 24 times 6. That's going to be 144 x to the 7th. All right, so now the next term, so I got that one done. So it's going to be x to the fifth. 5 factorial is 120. 1 minus x squared over 2 plus x to the fourth over 4 factorial minus x to the 6 over 6 factorial. So that's going to be a x to the fifth over 120 minus x to the seventh over 240. All right, so I got my first, I got my second, I got my third. Um, so now the only other one is going to be x to the seventh. So this is a negative over 7 factorial. So 7 factorial is a resounding 550 40 times 1 minus x squared, 2 plus yada yada yada. So I'm not going to have an x, I'm not going to have x cubed. I'm going to end up with this x to the 7th power. So I'm going to have x to the 7th power over 50 40. So now, so as a result, now I just need to add straight down because I'm literally just multiplying these two, the pieces, appropriate pieces um, for each of these. So what is going to be this cosine of x times the sine of x? But I just add straight down, so I've got x minus, it should be ending up as 2x cubed over 3 plus 2x to the fifth over 15 minus 31 x to the seventh over 2520 if you simplify everything down. So anyway, that's the first 4 non-zero terms. So it may be a little bit messy, but I'm just showing you, you just do, honestly, just manipulation. All right, so now on this one, I just want you to put it on pause and try this one. All right, so you've had a chance to read through it and try it. So on this one, well, yeah, on this one, we have we have um, we have e to the x. So we know that e to the x, let's try this again. E to the x is going to be 1 plus x squared divided by 2 plus x to the third divided by 3 factorial plus x to the fourth over 4 factorial plus x to the fifth over 5 factorial plus x to the 6 over 6 factorial. So that's our first 7 non-zero terms. So we also know that, and I'm just going to put it up here, that is sine x squared. So we know that sine of x is equal to x, which we just did just a second ago, minus x cubed divided by 3 factorial plus x to the fifth, well, x to the fifth over 5 factorial, um, minus x to the seventh over 7 factorial. So if I have sine of x squared, this is going to be x squared minus x squared to the third power divided by 3 factorial. So yada, yada, yada. But so what I'm doing is I'm adding to this a sine of x squared. And let me put it in an appropriate spot. So I've got x squared. So I've got x squared here. Okay. And then I don't have anything until this x to the 6. So x squared to the third power, you multiply those. So I've got x to the 6, and I need to subtract that over, it's actually 3 factorial. So that's going to be 6. Okay. So now let me go back up here, and I'm just going to change these just a little bit. Whoop. If I change them, and I get 2, I get 6, I get 24, I get 120, and then I get 720. So if I do that, then this e to the x plus sine of x squared is going to be 1 plus x plus, I should get 3 halves x squared plus x to the third over 6 minus x to the fourth over 24. I mean, that looks ugly. So let me fix that. So it's x to the fourth over 24 plus x to the fifth over 120. Oh, it should be a plus. Sorry. Sorry, plus. And now this last one is I've got 1 over 720. So 1 over 720 minus, so need to get a common denominator, 720. So that's 120 of those. That's what gives you 1/6. So I'm going to end up with a negative 119 x to the 6th power over 720. So that should be the first 7 non-zero terms of the Maclaurin series for this manipulation. All right, so hopefully that makes sense, and how you just manipulate things. So you should be good to go at this point. All right, so giddy up and have fun manipulating because it's actually pretty fun. All right, talk to you soon. Bye.